Hello, in this small video we are going to see linear regression and subsequently we will also see gradient descent. So linear regression is a statistical technique used to find relationship between variables. Okay, so if you have been given some variables, you want to have some kind of relationship and it has to be a linear relationship, then linear regression is the model which we can use. As an example, here what is established is that the weight of a car has a relationship on the mileage of the car. So if you have a specific weight, probably the mileage is linked very strongly linked to the weight of the car. So these are the numbers which are given. If you plot them, then they look something like this. The same table which we saw earlier is plotted here. And this line which is drawn here, this line is the linear regression line and also called model here, and which indicates that given a specific weight, you would be able to predict the miles per gallon, the mileage using this line. So as you know, linear equation is written as y equal to mx plus b, where m is the slope and b is the y-intercept. In terms of machine learning, it is represented in a different way. The concept is just the same. The representation is a little different. So the representation would be y hat. Y hat is the prediction equal to b, which was the y-intercept ahead earlier when we saw b plus w. W is weight and x1 which is the feature which we had. So it is the same as y equal to b plus wx. Now in a linear equation there may be linear regression, there may be multiple features which could be there which are helping us to derive the label, the predicted value, and an example of that could be like this. So here what is indicated is that you have different weights, which means different features which are there for predicting the y value here. So same example here, it is engine displacement, acceleration, number of cylinders, horsepower. Probably all these things indicate the mileage of the car. So that's where different variables are used here to indicate the equation. Okay, till here the content which I have taken is from the machine learning crash course. Now going forward, the example shall be mine. So this is the example. We have been given some features, some x value and the predicted value, which is the label. Okay, so these are the feature values and these are the label values. And what we have to do is we have to form a regression, linear regression equation, which would predict the value given any feature. So here what I'm doing is I'm ignoring the bias part, the B part. Now the question is why I'm ignoring? Because I want to represent this equation in DESMOS calculator and that too in DESMOS 2D for quick visualization. That's where I don't want to focus on the bias part, and bias I have ignored completely. So the predicted value here is y hat equal to w into x. Now for the loss, there are different ways to measure the loss. One prominent way to measure the loss is mean squared error. We have done the summation of predicted minus actual square and we have taken a mean of that. With our data set which was there, if you feed in the values of that data set, you will get this equation 1 by 5 and summation of w into x1. First value was 1 and the actual value was 1.8. So this is the predicted value minus 1.8 and you are squaring it and you're summing over all the samples, all the 5 samples which we had. And with this, you will be able to form the equation. Okay, if you open this, you will form the equation. The other way which is typically used is this way. The first and the second way is basically the same. In the second way, what we have done here is you have expanded this equation. So if you expand this equation, it will become w square plus yi square. Okay, so same thing has been represented here. So this and this are same. And this how this 55 came? If you do xi, summation of xi squared. So sum sigma of xi, different values of I, and you square them and sum them together, it will be 55. So this leads to 55, and that's where you have a 55 here. And this is the other component which we had seen earlier. Okay, now if you expand this equation or you expand this equation, both of them, if you expand them, then you are going to get this value. Okay, important to note, summation of sigma xi yi, you are multiplying both the values, the feature and the label, and adding them up, it is coming to 110, and the label squared is coming to 221. Okay, and that's what you have fed there in the equation, and this is the final equation you got. Now, this is the loss equation which we have found. If we have to make the linear regression line, then what we have to do is we have to minimize the loss. So what is the value of W where the loss is minimum? That is our intent. And how do we do that with the help of DESMOS? Let's open DESMOS and see there. So I've opened the DESMOS, and what I have done here is that the loss equation which we had, I just copied and pasted it here. So what I'll do here is instead of W was the weight, I'll represent the weight with X. Okay, because XY is little easy to work with in DESMOS. So I'm going to make it X square, and here it is X. So this equation which you see here, this is the same equation as what we saw here. Okay, the loss equation. So this is the loss equation. Only change which has been done here is instead of W, I have used the X. Now we can find the derivative of this equation very easily. How? Let's say that this is the derivative equation, and the derivative equation would be this. So this is indicating the derivative of this function, the loss function at any given point. So this function, the loss function we have created now, the derivative, which I'm not showing you right now, but derivative equation has been created. Now let's say that we have to have the different points on the graph. So what I'll do is I'll just create a, let's say I'll create a slider called x1, and it has value from 5 minus 10 to 10. I can give any value if I slide like this. And then for this x1, I would have a point on this graph, this function which I have. What is that point? If I give x1, comma, f of x1, then this is what would indicate me a point on the graph. So this is the point. Okay, I'm moving here and there, and you can visualize the point. Let me restrict it to minus 5 to 5. Now at this given point, if I have to create a tangent line from here to here, so tangent line, how can I create? So tangent line I can create by finding the slope at this specific point, and I can use the point slope form of the line, which is something like this: y minus y1 equals to mx minus x1. Okay, now the question would be, what is m? What is the value of m? M at that specific point, at this specific point, the slope would be equal to g of x1, because x1 is the point and we are trying to get the slope here. So this is the equation line which we have formed. And why it is complaining? Because I have not defined y1. That's where it is complaining. But what is y1? Y1 is same as fx1. So instead of y1, I can write f of x1. So now what I have done is at any point I'm going to predict, not predict, I'm going to visualize the tangent of the curve at that specific point. Now in gradient descent, what happens is you find the gradient, you find the slope, and then you also ascertain what is the direction the slope should move. So let's create a value which is representative of the learning rate. Let me call it as A, and let me say it has a value of 0.1, and the values would be 0 to zero point 0.1. So it's again a slider which has a values from 0 to 0.1, and if I have to call x2, which is the next value based on the learning rate and based on the slope. Okay, and let me say that I want to print this, so I'll say x2 comma f of x2, and let me call it as a label also. Now this is also red point, so it is basically not visible, but let me change the color of this point. Okay, yeah, we have this point now, and instead of representing the value of this point, let me call it. So on the next step, where exactly the graph will move. Okay, so this is the specific problem which we have if in case our learning rate is very high, which means graph moves from one place to another and it does not come to the local minima. So I'll reduce the learning rate. I'll make it little less. Let's say I make it this much. Okay, so what it is indicating now? It is indicating that when I have this point, the next point where I have to go is this point. Okay, and then if I go to this next point, then the next point would be somewhere here. Then the next point would be somewhere here. Then the next point would be somewhere here. And certainly after a while, after moving it down, I'll reach the minima. Okay, so let's see how. So you see here, you see here, you see here, and finally you reach the minima. Okay, we'll see what exactly is the minima of this function. And same from this place also. On from the right side also, it will indicate you which step to take to reach to the minima. So what would be the minima here? Minima would be, so this is basically minima. Otherwise, what you can do is if you make the derive this value, the derivative of this equal to 0, that's how you can get the minima as well. This graph basically indicates that what is the next step which you have to take to reach to the minima and then where exactly you are converging the graph. So what is the meaning of converging? Converging is the place where the reduction of loss is very, very minimal or equal to 0. That's where the graph converges. That's where the loss converges. There is no further loss we can ascertain beyond that point. And this is what is written here, that in this parabola for the loss curve, the minimum is at, you have to take the derivative, and derivative you have to make it 0, then this will be around 2. At around 2 you have the minimal loss, and that is what you have to predict. So what is the equation? When you have predicted the value of W, which means 2.0, then your model would be y equals to 2x. So the model is y equals to 2x. And you can see here that it fits properly. If the value of x is 1, then y is equal to 2, around 2. It's not exactly 2, but it is around 2. So our equation is y equals to 2x because we found w as 2. The weight we finally, with the help of reducing the curve, reducing the loss, we found that the weight is 2. So if you feed the value, so for example, if you feed the value of x1, then y comes 2. If you feed 2, the y comes, this is the predicted. So y hat predicted value would be 2. Here the predicted value would be 4. Here the predicted value will be 6. Here the predicted value will be 8. And here the predicted value will be 10. So this is the equation which our regression, linear regression has given. And this basically matches the labels which are given in the equation. So if you have a value of 6, if somebody wants to say, find out what is the value of label if in case feature is 6, then our model will give a value of 12. Why? Because 2 into 6 is 12. Thank you very much.